Okay, I guess they're real and you need to hear them. Let's get started. Number 7. The Fermi Paradox. An ordinary lunch in 1950. At the cafeteria of the Los Alamos National Laboratory, physicist Enrico Fermi was having a conversation with his colleagues as usual. The topic was UFOs. Newspaper headlines were filled with flying saucer reports in those days. Fermi laughed. He thought for a bit. Then he surprised everyone at the table. But where is everybody? 4 words. But these words gave birth to one of the darkest cosmic mysteries that remains unsolved to this day. Now, think about the numbers. In the Milky Way galaxy alone, there are approximately 400 billion stars. Planets revolve around the vast majority of these stars. Data from NASA's Kepler Space Telescope shows that a significant portion of these planets are in the habitable zone, meaning at a distance where liquid water can exist. Astronomers call this the Goldilocks zone. Not too hot, not too cold. Just like in the Cinderella story, just right. And this is just the Milky Way. There are 2 trillion galaxies in the observable universe. 2 trillion. Think about this massive number. The human brain cannot grasp trillions anyway. When you try to grasp it, it stays out of the game at some point. Perhaps this is not a coincidence. Perhaps the universe does not want some truths to come to light. When you take these numbers into account, mathematics leads you to an inevitable conclusion. Statistically, it is nearly impossible for intelligent life to have evolved only once, only on our blue dot. But then Fermi's question returns, that stinging, ruthless question. But where is everybody? If there should be this many civilizations, why is there no signal? Why is there no visit? Why this immense deep silence? The answers given to this question are the kind that will disturb your sleep at night. First possibility, the Great Filter Theory. This theory, put forward by thinker Robin Hanson in 1998, says, in the evolutionary process, there is such an impossible, such an insurmountable obstacle that almost no civilization can pass it. And now, come to the truly scary question. Is this great filter in our past, or is it ahead of us? If it is in our past, if we somehow pass that insurmountable threshold, we are lucky. We are the result of a rare miracle. But if the great filter is still ahead of us, then it means there are civilizations that started everywhere in the universe, but always reached the same inevitable end. And that end is approaching us too. Second possibility. Maybe aliens exist. Maybe they are much more advanced than us, but they are intentionally staying silent. Maybe the universe is a place where those who speak cannot survive. Maybe silence is defense itself. Lighting a fire in the cosmic forest is attracting predators. And us? We have been emitting radio signals since 1974. Our television signals, radars, military communication waves have been scattering into the universe for years. Every civilization within a 50-light-year radius, if they exist, is quietly watching us. We have already lit the fire. Fermi's silence was not an answer. It was a warning. Number 6. The Drake Equation. November 4th, 1961. Green Bank, West Virginia. The large dish antenna of the National Radio Astronomy Observatory looks at the sky in the cold morning air. Young radio astronomer Frank Drake is preparing to ask the most daring and terrifying mathematical question in history. Drake had a piece of paper in his hand, and on that paper, an equation was written trying to calculate the number of intelligent civilizations in the universe. This equation is known today as the Drake equation, and this equation stands exactly at the center of one of humanity's most important questions in scientific history. Each variable represents a probability. Star formation rate. How many of these stars harbor planets? How many of those planets life can form on? In how many life actually emerged? In how many intelligence evolved? And how many of these intelligent beings can create detectable signals? The last variable is the darkest, L. How long a civilization can survive. Now, do you know what happens when you try to fill this equation with real data? The difference between estimates reaches astronomical proportions. Optimistic estimates
There are thousands, maybe tens of thousands of active civilizations in the Milky Way right now. Pessimistic estimates? Right now, there is only us in the Milky Way, and no one else. But this is not the most terrifying part of the Drake equation. Its most chilling part is the L variable, the lifespan of a civilization. The duration that a civilization reaching the technological age produces detectable signals. Look, we started producing radio waves in the early 1900s. That means the duration we have been detectable is about 120 years. If a civilization is destroyed shortly after this stage, by its own technology or its own nature, then what does the Drake equation say? If the detection window in civilizations that are in a great position according to us and at a perfect age according to us is this small, then it is almost impossible for them to find each other. The universe might be a library with thousands of books inside, but each book written on a different shelf, on a different floor, in a different century. None can see the other. None can hear the other's voice. And when each light goes out, when it goes out silently, no one even notices. Drake's equation is not actually an answer. It is a framework. What you fill it with is up to you. But whichever values you put in, the place the equation takes you always ends up at the same question. Why is there no one around us? Or a more accurate question, is there really no one around us?
Number 5. The WOW signal. August 15, 1977, Delaware, Ohio. Ohio State University's giant radio telescope, Big Ear, continues to scan the sky. Astronomy PhD student Jerry Amon freezes while reviewing the telescope's results. He sees a signal on the computer printout, and this signal is different from all the signals humanity had detected until that day. Amon takes his red pen. He writes the following in big letters on the paper. Wow! And for the first time in history, a signal is named this way. What is the WOW signal? It is a high-frequency radio signal broadcasting around 1420 megahertz, exactly matching the emission frequency of hydrogen. This frequency is seen as very important in astronomy, because there has been a consensus in the scientific community for a long time. If a civilization in the universe wanted to communicate, it would use this universal frequency, a cosmic general channel that everyone who reaches it can understand. The signal was recorded for 72 seconds. This was the scanning range of the Big Ear telescope. For 72 seconds, the signal came at exactly 30 times the strength of the expected value, and then it suddenly disappeared, and it never came again. In the following decades, hundreds of researchers tried to explain this signal. Every possible natural source was examined. Satellite interference? No, there were no satellites in that region in 1977. Ground-based interference? It was checked, not found. The region where the signal came from was in the direction of the Sagittarius constellation, pointing to a region about 120 to 2200 light-years away from Earth. In 2016, 2 Canadian researchers put forward a new theory. The signal might have originated from 2 comets near us. This study laid the foundation for a debate. While some astronomers were convinced, most were not, because the characteristics of that signal did not exactly match any known natural source. Now, think about this for a moment. In 1977, something 120 to 220 light-years away sent a signal. If it took 120 to 220 years for that signal to reach us, what was on Earth when that signal was sent? A time between 1757 and 1857. The Industrial Revolution. Steam engines. Not even electricity yet. No radio. It's impossible to think of the internet. At that moment, something in the depth of space sent a signal towards a world where there were not even radio telescopes yet. And that signal passed in front of us in exactly that 72-second window when Big Ear was scanning the sky. Was this a coincidence? Maybe, but the word maybe does not comfort us at all in this case.
Number 4. Oumuamua, October 19, 2017, Haleakala Observatory, Hawaii. Astronomer Robert Wyrick was reviewing data from the Pan-STARRS telescope, a routine day's work. They were tracking near-Earth objects. Then an object caught his attention. Initially, they thought it was a comet or an asteroid,
But when its orbit was calculated, Weirich and his team froze in shock. This object was not something from within the solar system. For the first time in humanity's recorded history, we had detected an object coming from another star system. They named it Oumuamua. In Hawaiian, a messenger from afar arriving first. It was the first messenger, and the news it brought caused the scientific community to split in two. Oumuamua wasn't just strange. Oumuamua was impossible. Look at its shape. Unlike all known asteroids and comets, Oumuamua had an extremely long and thin structure. According to estimates, its length was 5 to 10 times its width. Flat, smooth, cigar-shaped, or like a thin disk. Natural cosmic bodies do not look like this. Erosion, collisions, formation processes all usually appear in rougher, irregular shapes. But the real shockwave came with its movement. Oumuamua gained speed as it approached the sun, but it gained more speed than the expected amount. An unaccountable acceleration, as if something was pushing it. Scientists tried to explain this acceleration. This happens in comets. Gases evaporating with the sun's heat push the object. It's called outgassing. But no such gas emission was detected in Oumuamua. No gas output, no tail, no dust cloud. Then where could that acceleration have come from? The chair of the Harvard-Smithsonian Center for Astrophysics, the respected astrophysicist Avi Loeb, published a paper in 2018, and this paper fell onto the scientific world like an asteroid. Loeb was saying this: that acceleration can be explained with a light sail, a thin, wide, artificial surface that moves using the pressure created by sunlight. And if this is an artificial object, by whom was it made? In the following years, Loeb turned this idea into an extensive book, Extraterrestrial, the first sign of intelligent life beyond Earth. It contained meticulous scientific arguments. The reactions were mixed. While some of his colleagues took Loeb seriously, some rejected him harshly. But no one could give a definitive answer, because Oumuamua was no longer nearby. During its 2017 passage, it could only be observed for a few weeks. Then it disappeared into the darkness of the solar system. In the direction it went, towards the Pegasus constellation, there is nothing. No home star could be detected. It just came. It just passed. And the scientific world is still not even sure what it was.
But think about this. We saw this object passing through the solar system, having an odd shape, carrying an unexplained acceleration not fully fitting into any known category completely by chance. The Pan-STARRS telescope was scanning that area that day. If there had been a difference of a few days, we might never have seen it. So how many have passed before, silently, without being observed? How many more are there that loop around the sun once and disappear by returning to the darkness?
Number 3. The Phosphine Scandal, September 14, 2020. Astrobiologist Jane Greaves from Cardiff University published a paper in the journal Nature Astronomy, and that paper carried to headlines all around the world. Phosphine had been detected in the atmosphere of Venus. Phosphine, a combination of phosphate and hydrogen, colorless, extremely toxic, a gas that smells like rotting fish. And it has a very interesting feature. It is extremely difficult to produce phosphine in nature. Planets, volcanoes, lightnings, all of these can only produce trace amounts of phosphine. But the amount of phosphine detected on Venus was far more than could be explained by all known geological and chemical processes. In astrobiology, phosphine stands in a very important place. On Earth, in oxygen-free environments, in swamps, at lake bottoms, in the intestines of some organisms, certain anaerobic bacteria can produce phosphine. In other words, phosphine can be a biological sign. It can be a clue to the existence of life. And this clue had been found on the Hell planet. You probably know Venus, the hottest planet in the solar system. An average surface temperature of 465 degrees. sulfuric acid clouds, and atmospheric pressure 90 times that of Earth. Every spacecraft that landed on its surface was crushed, melted, and turned to dust within minutes. But at a certain layer of the atmosphere, at an altitude of 48 to 60 kilometers, the temperature and pressure approach Earth conditions, and exactly in that region, phosphine had been detected. The news shook the world deeply. Even NASA had to make a statement. Some scientists were very excited. Some were more cautious. Then criticisms began to arrive. Reanalysis of the data raised some doubts. It was argued that the amount of phosphine was much lower than initially explained. It was discussed that there could be systemic errors in the telescope data. Greaves and her team defended the data. The debate continues even today. But think of it this way. Venus is called Earth's twin planet. Similar size, similar mass, similar age. Some theories suggest that Venus was a temperate planet with liquid water like Earth billions of years ago. Then something changed. Climate catastrophe, a runaway greenhouse effect, oceans evaporated, the atmosphere turned to poison. And if there was life on Venus during that process, maybe that life escaped to the sky. Maybe at the end of a billions of years adaptation process, inside sulfuric acid droplets, it still continues its existence in the atmospheric layers of Venus. Maybe Venus is showing us two things at the same time: how stubborn and inclined to survive life is, and how a planet can ruin itself. Whether that phosphine exists there or not, the mystery of Venus will always be a mirror held to Earth.
Number 2. Enceladus and Europa. November 2005, the Cassini spacecraft was approaching Saturn's moon Enceladus. It was a routine pass in terms of mission planning. The science team would collect their data, image the surface, and move on to the next target. But Cassini did not do a routine thing that day. It detected massive water vapor and ice crystals erupting from the polar region, giant cryovolcanic columns. Materials launched hundreds of kilometers high were forming Saturn's E-ring. What was underneath? An ocean of liquid water. The existence of a salty and temperate ocean, which has probably existed for millions of years under the ice shell of Enceladus, was confirmed. And at the bottom of this ocean, structures similar to deep-sea hydrothermal vents on Earth. Hydrothermal activity, energy source, chemical material, darkness, and heat were detected. On Earth, life may have evolved exactly in these conditions, around deep-sea vents. No need for sunlight, no need for photosynthesis, just heat, water, and chemical energy. Enceladus has all three. In 2017, Cassini passed through these columns, and it found organic molecules inside them. These are hydrogen, carbon dioxide, methane, precursors to amino acids. No one can help but ask themselves this. If there is already organic material in these columns, what is inside the ocean? Now let's ask the same question for Jupiter's moon Europa. Europa is much larger than Enceladus, and it is estimated that there is a saltwater ocean 2 to 3 times the size of the total volume of all oceans on Earth under its surface. Think about it. Take all the water on Earth, put 2 or 3 times of it under the icy shell of Europa, in pitch darkness. NASA's Europa Clipper mission was launched in October 2024. The goal is to reach Europa in the early 2030s and try to answer this question. But when the answer arrives, we are not sure what we would want to hear. Because think about this. If there is life, or if life has existed in more than one region within our solar system, in this tiny, desolate, ordinary corner, then it means there is life everywhere in the universe. In every ice-covered satellite revolving around a planet, in dark, cold oceans far away from stars, silently, without being seen, unaware of us, and us, unaware of them. Doesn't this disturb you too? The idea that we are not alone? Or is it more terrifying to realize how this universe is overflowing, how loud it is, but none are aware of the others? Perhaps the darkness of the oceans is the most crowded place in the universe. We are looking at the sky and seeing a silent void, but maybe, beneath the ice, in the depths we cannot reach, The universe is bustling with life. We are just waiting for the day we finally touch those hidden waters.
Number 1. The dark forest theory. Chinese science fiction writer Liu Cixin completed his novel The Dark Forest. He was proposing an answer to the Fermi Paradox. And this answer is one of the coldest, cruelest, and most scientifically defensible hypotheses you have ever heard. Liu Cixin's theory is based on these postulates. First, every civilization wants to survive. This is an innate feeling. Second, resources are limited. The universe is big, but matter and energy are not infinite. Third, civilizations cannot fully know each other's intentions. When two civilizations encounter each other, you cannot understand for certain whether one will pose a threat to the other. Fourth, technology grows rapidly. A primitive civilization today can become an existential threat 100 years later. The conclusion that definitely comes out of these 4 postulates is this: to explain that you exist at any point in the universe is to bring your own end. Because for every advanced civilization that notices you, the most logical move is to destroy you as soon as possible. Spending time to get to know you, allocating resources to examine you, trying to communicate with you. All of these are risks, and on the cosmic scale of the universe, taking risks will threaten life. If there is a grain of truth in this theory, the universe is silent because everyone is keeping quiet. It is like a dark forest, full of hunters you aren't even aware of. And the first child who lights a fire in the forest cannot see the morning. We sent the Arecibo message in 1974. Through the giant radio telescope in Puerto Rico, we sent a message describing humanity to the M13 cluster in the Hercules constellation 25,000 light-years away. To receive an answer, it is necessary to wait at least 50,000 years. It will go there and come back. But according to the dark forest theory, an answer might not come. Instead, something different might arrive before an answer is given. And after we sent this message, we realized, once you make the sound, there is no way to silence it. So which of these theories is correct? We cannot know. Maybe it will never be known. Maybe when we learn the answer, we won't have the time to benefit from this information. Let's return to Fermi's 3 words. But where is everybody? Maybe they are very far away. Maybe they perished long ago. Maybe they are asking the same question. Maybe they are keeping silent because they learned that keeping silent is the only way out. Or maybe they are watching us right now, and they are choosing not to make their voices heard yet. The universe is 13.8 billion years old. Human civilization is a few thousand years old. Our technological age has not even reached 100 years. In this cosmic timeline, we are just a newborn child. And no child, no matter how loudly they scream, can prove they are not alone in the dark room. If you want to see more videos like this, don't forget to like the video and subscribe.